Welcome back to Gundy's Garage. I've got a bit of a quick follow-up video here. Almost an apology, I guess, to Mark. I don't feel that I really showcased his RF OFF particularly well in the last video. I've been back over a few things, and it's clear that I didn't give it a fair chance. So the video quality that you saw in the last video that I did about the Commodore 16, the upgrades, I mean, I showed the output from the thing in the end, but I really didn't do it justice, and I'll go over a few reasons why that's the case. This was the setup that I had. This is my RetroTink 4K. Sorry, I'll just push those cables out of the way. This is my RetroTink 4K, which the Commodore 16 was plugged into using this S-video cable. We'll get into why that's important in a second. It's plugged in through the VGA port on the RetroTink. It's using what RetroTink calls the enhanced S-video input, which gives you some extra options as far as tuning the DACs and stuff in the RetroTink and the decoding of those signals. We can have a look at that as well as we get into it. And the other thing, I guess, that's important, and we'll get to why in a second, is the power supply that I was using for the Commodore 16 at the time. So let me just show you the power supply first. Oh, actually, no, before I do that, let me just, we'll have a look at the video output when I turn the computer on. This is essentially what you get without really tweaking things too much. And at the moment, I've got shadow mask turned on, so it's a little bit fuzzier than you might expect it to be. But you can see that there's problems with the synchronization there. There's all sorts of noise on the picture. There's lots of stuff going on. I will show you just really quickly with the RetroTink, you can tune some of that out. So if I go to the advanced settings here, I believe under the ADC section, we have a sync on green threshold, and I believe if you increase the voltage there, it starts becoming a little bit more stable, but you can still clearly see there's a lot of noise and stuff in the picture. It is not looking great at all. So I'll just put that back to where it was. We'll go back to the mess, and I just want to show you something really quickly because I found this interesting. Obviously, you can see I'm using a pretty crappy cable here, but I'll show you the other part of what was happening as well. I was using one of these power supplies. It's a switch mode power supply. Let's see if the camera will focus on that for you. A Schnitt power. Now, I don't know whether that gives you any sort of hints. Probably should have given me some hints. Power supply called Schnitt power. Anyway, like I say, it's a switch mode power supply. At the time that I made that last video, that was all that I had available to me. The Commodore 16 didn't come with a power supply, so I just quickly ordered that off Amazon to get it up and running. It has these adapter bits as well that allow me to go from center positive to center negative, which is what was needed for the Commodore 16. After the video was made and released, I managed to get hold of one of these, which is a actual proper Commodore 16 brick. And again, camera, come on. So this is the correct power supply for the Commodore 16. It has it's obviously like very heavy. It has a transformer in there, I'd imagine, and some sort of a linear regulator. But anyway, what I'm going to do is I'll plug that in now and show you what we get as far as the output is concerned on the screen. So if I plug the actual Commodore power supply in, and we'll switch back over to the RetroTink. Look at that, nice, clean, clear picture, even using the crappy cable that I've got here. So That's, I guess, a bit of a trap that you might need to look out for. If you're going to use crappy S-video cables, I'd recommend using a good linear power supply that's nice and clean, and maybe vice versa. Like if you are going to use a crappy power supply, I would consider using very good S-video cables because there's obviously just a lot of noise and crap being sprayed off the board and stuff and making its way into the S-video signal, and that was really affecting the RetroTink's ability to sync on that signal. So as you can see, the picture already looks a lot better, but there's a lot more that we can do with it as well, and we'll get into some of that. Before we do that, I just want to show you really quickly what it looks like if we plug into the front input on the RetroTink. So the RetroTink, obviously I'm using the rear port with the laser bear adapter there for the enhanced S-video, but the RetroTink also has a port on the front of it that allows you to plug S-video signals in as well. The front port, unfortunately, is pretty stiff on mine. It's hard to get the cables in. However, let me now switch over back to the RetroTink. We'll go and choose the front S-video input. And again, we have a beautifully clear signal there. Actually, while I'm here, I'll just jump in and we'll turn off some of the processing effects. So we've got scan lines turned on, we've got blurring happening here, so I'll turn that off to nearest neighbor. We'll turn the anti-ringing off, linear light off, and we'll turn off the mask as well. And hopefully you can see that already is a pretty good looking signal. It's very similar to the signal that Mark sort of showed us on his video. There is still, I guess, high frequency jail bars in the border you can see there in that purple part of the screen. But it's generally, like, to me, that's not looking too bad at all. And honestly, I was a bit disappointed when switching from the front S-video on the RetroTink, which is supposed to be the crap S-video, not crap, but not the best that it has to offer, and going to the enhanced S-video. So again, let's switch back to enhanced S-video, and I don't know about you, but to me that picture looks worse than we had before. For a start, the banding in the border is a lot more irregular. The text itself looks fuzzier, I think, and the general overall quality of the picture is not that great. So, looking at that, I was like, okay, well, obviously, I want to try and show Mark's RF off in the best light possible. So I have another S-video cable that is comparatively, compared to the other one, it's probably about twice as thick and just looks a lot fancier. So I'm going to try that out and we'll see if that makes a difference to the picture. And let's just remind ourselves again of what that looks like at the moment through that enhanced S-video. Let's try the more expensive cable and we'll see what we get there. Okay, so with the fancier cable, you can see that we've massively reduced the striping in the picture, so it is looking even better again. So it's brilliant, like it's looking a lot better, but I think we can do even better than that still. So we're going to jump in and tune some of the settings on the RetroTink and see if we can make it, make it even better than it is now. And I'll show you some of the settings that we're going to look at. So first of all, we're going to jump into the component ADC here. This was the place we were before. And you can see that the maximum color that we're getting through on the signal is only going up to 200 of 255. And this is one of the things that Mark commented on in the video. Oh, you know, I should make sure that the white looks a lot whiter. So with the RetroTink, this is a setting that we can use for helping with that. So I can increase the gain on that green signal to get it up to much closer to 255, which is maybe around there. We're kind of maxing it out already. It obviously looks a lot better again. Now, the other thing that I'm going to do here is the sampling section. So I'm not sure whether you can see clearly, but the text itself is a bit fuzzy. And I think part of the reason for it being fuzzy is that the way that the samples are taken with the RetroTink, we're taking 3,528 samples per line, but that's not a clean multiple of the dot clock or the horizontal clock in the TED chip, or that the TED chip spits out for PAL machines. So I'll show you just really quickly the data sheet for the TED chip. And you can see here where it talks about the horizontal position register, it counts 456 dots total per line, ranging from 0 to 455. It took a bit of digging to figure this out, because I've tried to set things up for the Commodore 64 before, and the Commodore 64 uses 504 dot clocks per line. And for whatever reason, when I was setting things up initially, I had assumed that these would be the same. I couldn't have been more wrong. So in order to get a clean multiple of 456 samples, I need to drop this down to 3,192, and that will give me a multiple of 456. It will give me 7 times 456 gets 3,192. And you can already see there now, look, that text is looking a lot clearer than it was. There's, you know, not as much of that kind of shadowing and stuff going on as there was before. I think the RetroTink can probably do a little bit better still, so I'm going to do an auto calibrate on the phase here and let it figure out how it needs to set stuff up. Has that made it better? I don't know. I feel like it might be a bit out, to be honest. I'll try that again. Okay, there we go. That to me is looking pretty good that time. So I think the first time it may have got it off by a bit, but it looks like it's got it right this time. You can see that it's picked it up as a multiple of 7 there. The decimation factor, 456 is the, as I said, the number of dot clocks that the TED produces per line. And now we're starting to get something that looks a lot better than it was. I'm sure you'll agree. So there's still some other stuff we can do in here as well to make things even better still. There's some other sections. We have a color correction section. I'm just going to tweak this and apply a preset. So I'm going to set this to an sRGB preset. So that's brightened up some of the colors a little bit there. That purple looks a little bit more vibrant, which to my eyes anyway, looks a lot better. I don't know. I mean, I guess, you know, maybe that's a bit subjective. You can tweak that how you like. And then in the SDP decoder, there's some other stuff that we can adjust in here too. In order to do that, though, I really need to have the keyboard connected, or a bit more of a test pattern that I can set up. So just by way of explanation, while I grab the keyboard, what can happen is because the Chroma and the Luma are being sort of digitized and sampled separately, you can end up with a bit of an offset between the two of them, which means that maybe the color information arrives a little bit after the brightness information for the pixels, or vice versa. So what the Chroma offset allows you to do is to fix that problem. So what I'm going to do is I'm going to set up just a few blocks of color over here by turning reverse on, and maybe we'll create some red stuff. I might create some blue, and what are some other colors that won't go very well? I'm not sure whether you can see between the blue and the green there, but it looks like there's a bit of bleed between the colors, and we'll see if we can do something about that. I'm not sure whether we will be able to, but we might. I'll just create some pink stuff here too. So with the Chroma Shift here, what you can do, I'll make it obvious. So if I set that to something really high, you'll be able to see what's happening here as the colors will start obviously being out of sync with the luminance. So we're getting these extra bands of color there. So with the Chroma Shift, what we want to do is try and bring that to the point that that color bleed is minimized. And I think it might be to go lower. Have I gone too far? No. I feel like it's probably around there, sort of maybe that -4, -5 area. And that looks like it's sorted out the color bleed. Now there's still a few other things here. So if I choose orange, I'm just going to use Mark's favorite symbol, the pound symbol here. And I might create a few of those in some different colors. So that's orange, which as you can see kind of doesn't really look all that orange. I'll do a brown as well, which to me looks probably a bit darker maybe than it should be. The one also that I'm interested in is yellow on white, which is going to be, I imagine, probably quite difficult to see. Yeah, might have made that a bit too tricky. I might have made the screen, a bit too bright. We'll have a look at that. And what other colors can we go for? We'll go for a green as well. And maybe a red. Maybe I'll do all of the primaries. I'll do blue and red too. So blue and red. Where's red? There we go. So that red looks either too dark or a bit too desaturated. So let's see what we can do about that. We might be able to tweak those a little bit, either through brightness and contrast, or some of the color settings. So I might jump back into the color correction settings first. And let's play around with the input factor. Yeah. Makes it, I guess it's kind of like a gamma adjustment, and I don't know that I really want to tweak that too much. Maybe I'll try playing with the saturation. Okay, I think that maybe is bringing out the colors a little bit better. Do we have a light red available to us? Not really, we do have a pink. I think we're probably starting to look not too bad at the moment though. I could probably play with this for ages and I'll just end up making it worse and worse. So I don't really want to go around in circles too much. But to me that's starting to look pretty nice. It looks nice and vibrant. The pixels are all nice and sharp. The other thing we can do with the RetroTink is we can apply effects to it. I know I had them on before and I've just sort of turn them off for purposes of showing this, but we can also turn on, the shadow mask to give a bit of that sort of CRT effect if we want to. It does darken the image a bit though, so I'm not sure that I really want that on. Although often, like if I'm playing games and stuff on the Commodore 64, I do feel nostalgic for that. For that TV. look. So they've got a whole bunch of different things in here that you can choose. Like if you want, you know, like a 600 line aperture grill, you can do that. Anyway, we'll turn that off. Keep it nice and sharp. You can also tweak the vertical and horizontal kernels that you use for interpolation. So these are on bilinear sharp at the moment. If you change that, you can obviously make it look awful. Or you can go to something like nearest neighbor, which is probably going to be about as sharp as you'll get, but it also ends up, I don't know, I feel like it looks a little bit over sharp to me. So I generally end up settling on something like the bilinear sharp or one of the Lanxos filters, like Lanxos 3. Although there, no, to me that looks too fuzzy. We'll go back to maybe I'll go back to bilinear sharp. Like I said, I feel like you could tweak this all day. At the end of the day, it is an old system. It is, it's not RGB video. It's not ever going to be quite as sharp or as nice as those. However, I hope you can see that this is a lot better than it was in the previous video that I did. And like I said, I felt that I really needed just to put out something quick to show how many ways I had screwed up the original video, and how you can make things look a lot better just with a few simple tweaks. If you're interested, I'm going to publish the profile for the RetroTink 4K for the Commodore 16. I'll put a link to it in the bottom of the video. Feel free to download it if you've got a RetroTink 4K and a Commodore 16. I will also create a profile for the Commodore 64 as well when I get around to that, and I'll also upload that too. So yeah, hopefully that was a little bit interesting. Again, apologies to Mark for not really showing the RF off in all of its glory, but I hope this makes it up to him. Thanks, we'll see you next time.